So we're shifting gears now. Now we're talking 5G. So as Mark said, we all have night job. So my day job is at Netcracker, SDN My night job is co-chairing the Marketing and Education Committee, but my second shift is chairing the 5G focus group, which is now very, very important to the MEF. As you can see, 5G is not just another generation. You know, when we had 1G, we had the voice, 2G, we enhance it, 3G, we start open connectivity, but really 4G, we made the connectivity. 5G is not continuing that trend and doing much more than that, right? So what do I mean by that? I'll just let you know what I'm covering. So I'll cover what's new in 5G, why 5G is not just another generation. And then I'll talk about the 4 projects that MEF is working on related to 5G, which is transport for 5G, network slicing, orchestration, and services over 5G, fixed mobile conversion. So why do I say that 5G is not just another generation? As you see the path, really, we started enhancing the mobile broadband in 4G, and we opened it. With 5G, we're actually adding more use cases that we never had before. So obviously, we are enhancing the broadband. So enhancing mobile broadband, so we can have things like augmented reality and virtual reality, that we can actually have connectivity, wireless connectivity to your home, to different venues, and different devices that are not phone or tablets, right? But we also have new use cases. One is massive machine type communication. I'm talking about IoT. There are many, many types. Some don't require a lot of bandwidth, very narrow bandwidth like sensors. Some require a lot of bandwidth like image processing. And I'm also talking about critical machine type communication, manufacture, autonomous cars. Those are all machine type communication we never had before. And they impose a lot of new requirements on the network. All those use cases will drive more revenue. I like to say that the whole stack that the network operator deploy is going to change, from the network itself, control, orchestration, up to the OSS and BSS. Also, the billing will be different, like you don't bill the same even. So lots of different changes are coming with 5G. And that's the main reason why it's high focus at the MEF. So those are some technical attributes that 5G brings, not all related to network, but just I wanted to give some of them so you'll get an idea. So you're talking a very high data rate and peak data rate. We are talking about mobility, basically much better mobility than we had in 4G. Very, very low latency to support some of the machine type communication. Lots of different models. So, for example, we need for some very high availability. For others, it's the different machines. We are talking about battery for 10 years. So, for example, even before IoT, I just got a letter, I'm living in Maryland, that now I have to remove all my smoke sensors, smoke and fire sensor, and have a new one with the battery for 10 years, right? So that's what we want for IoT, that you won't have to maintain them for 10 years and then you just buy a new one. Reliability and availability is very, very important. So this is just to give you an idea, and we took it from different sources, from ITU, from NGMN, and from 3GPP, just to give you an idea what's coming with 5G. I mentioned the latency. So this is a graph that shows you the latency, and distance. Just to give you an idea, where do you need that high latency? And it's really for very short distance, right? Wind turbine, the high-speed motion. So here you really need the low latency, but it's close communication. It's not far away, so you can talk device to device or have the cell site switch the traffic, what we don't do in 4G. In 4G, everything go to the core and come back. In 5G, we can do it at the cell site. Robot, it's okay for 10 milliseconds, and then you have the communication. It doesn't need the latency that is okay with high latency and high distance communication. And you can see that most of the use cases, we are really talking about very short distance. Just reminding you, if you were not in the room before, ask question now, it's better. This slide I received from Ericsson is just show the prediction of revenue. We all hear eventually to drive revenue up. And as you can see, with 5G, most of the revenue will come from those new use cases. That most of them were not mobile in the past, like agriculture. Agriculture was not mobile. Financial, health, all of this, it's something new that will drive more revenue. For manufacturing, we are talking about Industry 4.0, basically another revolution in manufacturing that is all connected, right? So sometimes I'm in conferences that are not related to mobile, and people are saying, oh, 5G, it's coming, but it's 5 years from now. Don't worry about it. So no, 5G is almost here. It's here. So those are the use cases. So LTE Advanced, the high bandwidth is here. IoT, massive IoT, or IoT is here. I spoke to many of our customers in the US. They are deploying a lot of sensors. In my company, we have like 400, my mother company, and it's here, 400 deployment just of video analytics. So all those machine type communications, they are here. This is the IoT. Massive MIMO to have the high bandwidth, it's here. We are working on RAN virtualization. Low latency will come with the new RAN. And with regard to deployment of 5G, well, there are a few operators, Telia, Verizon, AT&T, a few others that would like to have 5G this year, before the end of the year. Most operators that I spoke with, they're talking about 5G in 2019, 2020. So this is where we'll see most of the 5G. So it's now. It's not 5 years from now. This is how we are going to achieve 5G, 1 gig. So are you familiar with carrier aggregation? Anybody not familiar with that? So we are taking a chunk of frequency and we put them together in order to get a higher bandwidth. And you can see this is with 2, with 3, and eventually with good coding, you can get with category 16, basically you can get to 1 gig. And there are many deployments for the low latency, but there is one deployment for that already reached 1 gig. So the high bandwidth is also doable. And with the millimeter wave, it's also much easier to do, which is also coming. So let's talk about the evolution, how it goes. So we have today, the 4G is LTE and LTE Advanced. Familiar what LTE stands for? Long-term evolution. So I love 3GPP. They already dropped it. It's no longer. It's now called LTE. And in release 13, they had LTE Advanced Pro. and they run out of what to call it less, they can't call it advanced, so now they are calling it LTE, LTE evolution. This is when engineers are making the names, right? So with LTE, you have the 8x8 MIMO. You can get, if you want, with care aggregation, you can get to 1 gig. You have VoLTE implemented, mobile broadband, and IoT, as I said, it's already on LTE. LTE is very good for IoT, much better than 3G, where the battery goes faster. With LTE evolution, we are talking about unlicensed bandwidth. We are talking about more low latency, lower the latency to have more machine type communication. And this will bring more massive IoT and autonomous vehicle and all of that. And what is NR? Anybody knows? Again, engineers giving the name. That's 5G radio. New radios. That's an N. So new radios, you are getting the higher frequency. You are getting larger bandwidth, ultra low latency, and with that, you can also get critical machine type communication. So remember, we had 2 types. One is machine type communication, massive machine type communication, which is IoT, and then the critical machine type communication. And this will come with the new radios. And obviously, for all those new use cases, you'll have a lot of new spectrum. So how is the evolution is going to go? With the EPC, and 5G enable EPC, you can get traffic from LTE radios, but also from new radios. And that's how you will start. You'll start with LTE, LTE Advanced, and some island of 5G. When you get more and more devices that are supporting 5G, you'll get more deployment. Eventually, you'll have your next-gen core that will take LTE and new radios together. So that's how we'll do the evolution. And obviously, we need the device support. And we are not just talking about phones, right? It's more than that. So let's talk a little bit about the challenges. Why do I say that it have a lot of new requirement that it imposes on the network? So the one thing that I would like to discuss is the functional split. You guys familiar with functional split? Okay, so in this, what we are trying to do, we are trying to get the radio to be more efficient. So what I'm doing, I'm taking the radio and split it into 2 or 3 pieces. So one, if it's 2 pieces, one is the remote radio head, and the other one is the digital unit. And between them, I basically have, instead of packets, I have more like RF. So I need more bandwidth. Now, this was used in the past a lot, but only only inside the tower. So you had the remote radio head in the tower, and then TDM basically going to the bottom, and in the bottom, the digital unit. Now we are trying to get it further and have the baseband, the digital unit together. Why do we want to do it? So first of all, we'd like to reduce bandwidth demand. If I ask here now, what is the most expensive, most critical resource that I have in mobile network? Anybody can tell me? What is my most critical resource? It's a spectrum. Yes, spectrum. So I want to reuse the spectrum as much as I want. So I have macro cell, I have small cell that are in the footprint of the macro cell. Using the same spectrum, I need coordination between the small cell and the macro cell so they will be more efficient. Coordination, the base station need to talk to each other. If I want real good coordination, what we call comp, I have to have very fast communication. So basically, the base station is saying, I'm servicing this guy, you are servicing that guy. Or now I have, now only I use the spectrum. So you need fast communication. They need to be together. How they can be together if each tower is separate, right? So I need to put them together. That's why I split them. I put the antenna where it need to be, all the base station together. So another advantages come out of it. I can virtualize the run, because now they are all together. I can put them on shared compute. So as I said, it's better for managing my resources, and I can do one split or two split. 3GPP did it to increase the flexibility in the deployment. So if we look at that, this is the radio, and there are 8 options to split it. And 3GPP, small cell phone, they all came with their idea where is the best place to split. The more you split closer to the radio, to the antenna, you need more bandwidth and low latency, but your benefit is high. The more you split towards the packet, you are more relaxed with latency, you need less bandwidth, but the benefit is not that high. That's the main idea, and that's what this is showing to you. So obviously, we are not doing 8 splits. We have option 7 and option 2. Those are the 2 main options that operators are selecting. And basically, I'll show you how the deployment changed with each one of them, because this is one of the MEF projects. So this was the introduction. Let's talk about the few projects that we are working on, and very important to the carriers. So the first one is transport for 5G. MEF traditionally did a lot of work with mobile backhaul. Now 5G is more than just backhaul. So those are a few examples of the transport. So you can see here the split, and we are talking about 5G distributed RAN and 5G cloud RAN. What is distributed RAN? I don't put all my digital unit together in the cloud, but I put them together in some place, like maybe I want to cover a stadium or a venue with a small cell, and this is distributed still. Or I can take all my base unit and put them in the cloud in one location. And with 5G, I don't have to use CPRI, which is TDM based. I can use eCPRI. If my transport meet the delay requirement, I can also use packet, which is an advantage. And based on the split, it shows you what you need to do. The advantage of the distributed is that it's shorter distance. Sometimes fiber is not available for longer distance, so you want to use that. For the cloud, you're talking about more longer distance. And this is what coming is the virtual ones. Once I have the split, I can virtualize. Typically, virtualization comes from the core. We already virtualize the EPC. The second that will come is the cloud unit, and later on maybe the digital unit. Once you virtualize it, you have the opportunity to add edge compute, to add some VNF in your edge and drive more revenue by providing more services. So this is what will come with the virtual RAN. And when you virtual all of them, you can put them together. You can support critical communication, edge compute. This will come, future. This is just to show you the evolution. I showed that slide with the 5G enable EPC. This showed the whole thing together. So you have your core, you have the centralized domain, you have the island of the new radio. So this shows you all the different deployment use cases. You have this distributed one, the centralized one, okay? Just as an idea. You don't have to do all of that, but it's good to have options. So what is our focus? Our focus is basically on the access, the transport, and once you have the virtual transport and the cloud, we are talking about application, and all of that need to be managed. So I'll talk later about the LSO, how we can manage the 5G network. So let's talk about the MEF work in all those areas. So we discussed, just to recap, we discussed the transport, we discussed the different attributes that we need to manage, and now let's talk about our work for that. Let's see how much time I have. So transport for 5G, we are talking about where the wire meet the tower, so from the tower to the core. That's transport. We discuss all the options. So you're looking at capacity, at latency, and decide what you need, if it's layer 1, and MEF come with layer 1 service definition, or layer 2, if it's EC3 or Care Ethernet. So this is from, we got it from ITU. This showed the different use cases that I discussed in the beginning of the presentation. The enhanced mobile broadband that has most of the requirements, the massive IoT and the ultra-reliable communication, the critical machine type communication. So you can see here how they impose requirement on the network, where the massive IoT is mostly on the density of the network, the critical communication mostly on the mobility and the delay, and the bandwidth, it's almost everything. So we took it and we translated it from user experience into network impact. What is the network impact? What do we need to do? What do we need to support? And obviously you can see that it's much more impact than 4G. So this is just to show what are the options. We have a front haul that we didn't do in the past. We are working on front haul. This is the bandwidth. And this is really in dense area when we need a lot of coordination. We need a lot of communication between the base station. And then there are a few other options that depend where you are. And as you can see, here we are talking about very low latency. Here the latency is relaxed. So we categorize the different options based on the requirement they impose on the transport. And based on that, we provide the option for deployment. So we already have backhaul. We are working now on front haul, and we also have mid haul. So if you're not familiar with the term, front haul is what used to be C3, now it can be EC3. This is between the remote radio head and the base station. Backhaul is what we did all the time from the macro to the EPC. And mid-haul, the MEF use it to describe the communication between the small cell and the macro, because X2 interface require some new or some other requirement than backhaul, so we call it mid-haul. I know that other standard body call mid-haul the communication between the DU and the CU. We'll have to resolve it, but I put our definition here, the MEF definition. So let's talk a little bit about the split. So I already showed that slide. We are looking at option 2, which is the higher split, and option 7, which is much closer to the antenna. We are looking at eCPRI to support the frontal, and for the second split, you don't need eCPRI. So we are looking at the two use cases: the use case of one split and the use case of two splits, right? And provide functionality on that. The work is ongoing, already started last year, and the project called Transport for 5G. You can join the calls. They are every Monday at 10 o'clock Eastern time zone. Let's see. Okay, let's talk about an important topic, network slicing. Anybody here not familiar with network slicing? Not familiar. Oh, some, okay. So let's cover it. I wanted to skip that slide for the few people that would like to know. So as I said, you have, I showed that slide before, right, that you have a lot of different requirements, and also you have different use cases. You have critical machine type communication, you have massive machine type communication, some very low bandwidth, some high bandwidth. Each one has a totally different requirement. The critical communication need to have very high availability, maybe very low latency, right? How do you deal with all those requirements? So one way is to say, I don't care. I have one network, right? And I'll try to solve whatever I can to the common denominator. That won't work well. The other way is to say, I'll build network for each use case. That will work well. I can have very fast layer 1 network for my low latency and packet network for my high bandwidth, but it's very expensive. So the way to do it is with network slicing. So I slice the network to have a virtual network with the requirement that I need. And then I have few virtual network, one basically just for IoT, let's say, one for critical communication, and each one has different characteristics. That's what we are doing with network slicing, okay? It's its own bandwidth. There is a total separation between the different slices. So this is the benefit of network slicing. I have a better customer experience because the customer is getting the slice that they need for the service that this slice is for. It's much shorter time to market than multiple network, more scalable, and if I can orchestrate it, I can automate it. So I have a lot of flexibility in my network. So what does it enable me? Basically, if I have, as I said, if I have network slicing, I can create slice per use case. I have lower OpEx. I have new revenue for those new use cases and better CapEx. So MEF is looking at network slicing. I gave you some example. This project started also last year, led by Sibyl from NEC. This, and what time are the calls? Thursday, I think at noon. Thursday at noon, if you want to join the calls, noon Eastern time. So we are looking at different slices. And by the way, a slice can be an EVC. Carrier Ethernet support slicing. It's Ethernet virtual connection, right? So we can do it with Ethernet, we can do it with other technology. We are looking at all of that, provide a toolkit for the mobile operator to do slicing. This is an example of how we do slicing. We can do it, as I said, with Carrier Ethernet, with S-Tag, if you're familiar with S-Tag, either single S-Tag or double S-Tag, but we also can do it with MPLS or with PBB. So those are examples. The standard is not completed yet, but will be soon. And this is a 3GPP view of the slicing. So remember, when you do slicing, you need to do it on the mobile network and on the transport network. And you need to coordinate that. Otherwise, it won't work. So this shows you from the device to the run to the transport. So this is the first time, 3GPP guys up till 4G, they view the transport as infinite bandwidth, zero delay. That's it. We don't care about it. We worry just about the radios. It's not anymore. Now we are talking about coordination between the transport and the mobile in order to make the slice work, right? So that's a very, very important thing that we need to support as well. So if we are talking about slicing, we need to talk about orchestration. So we have the mobile LSO, the transport LSO, and now they need to talk together. We need to have domain orchestration. We need to have domain orchestration to support end-to-end services. We need it to support slicing as well, because we need to coordinate between the mobile domain and the transport domain. So when you say 5G, we also discuss, you're saying also NFV, Cloud Run, you're also saying SDN. Everything needs to be orchestrated. So end-to-end LSO, what we call it's the mobile and the transport LSO. It can be different. It doesn't have to be, it's two different domains, but they need to be coordinated. So when we talk about slicing and about orchestration, talking about data-driven orchestration, so for network slicing, basically are going to have a catalog, and that's how you will support it from orchestration perspective. So you can select the slicing you need based on your requirement, right? And I gave you here a few examples on the different services. Each one have its own slice, like eHealth, a slice, media is a slice, robotics. That's the main idea. So when we talk about orchestration for 5G, this is part of our LSO. 5G is one of the use cases. We're talking about multi-operators. You saw you have different split. Sometimes it will be different operators, different transport operators. We're talking about multi-technology. It has to be multi-domain. We are talking about the whole life cycle. So it's not just provisioning. We are talking about service OEM, service activation and testing, service assurance. And we have different projects on that topic. So this is the whole view of the 5G. We have the network. We are talking about virtualization, about SDN, cloud run, network slicing, all managed by lifecycle service orchestration. Those different domains, different slices, different function, different edge function that you can deploy. That's the main idea. Last thing that I would like to cover is services over 5G. This is the fixed mobile convergence that many operators would like to have. So you can tell me we spoke about it at 4G, it never happened. 4G did not have enough use cases, and also the bandwidth, we hardly reached to 1 gig, so we couldn't do it in 4G. Now with 5G, we can do it. The whole idea of fixed mobile conversion is that we are going to have seamless handoff. So we have either wireless network, wireline network, it doesn't matter for the user. The access, if we cannot have fixed access, we'll have mobile, what we call fixed mobile access. And why do we need it? First of all, customers want to have the same experience, whether they're at home, at work, with their mobile device, with their fixed devices. As we know, fiber availability is not all the time available. One thing that I see a lot in the US, maybe it's also in Europe, people decommission their TDM network. And when I talk TDM, I'm not talking just E1, T1. You wouldn't believe you have 2.4, 9.6. I'm old enough to remember. I don't know if everybody here remember the 2.4 modems, the 9.6, the 64K, and they are running critical traffic. And it's not that people want to decommission them, but they can't keep them alive. Nobody manufactures them anymore. And you can't bring fiber to a 2.4 connection or 9.6 connection. You'll use 5G or you'll use LTE for that. So this is one big use case, and you can see it in a lot of rail intersections, those modems. So now it will be wireless devices. And another thing is very easy CapEx. You know, instead of digging fiber to a small customer, I can just ship a box with an antenna. We have a customer at Netcracker that use it in all their FedEx location. They have a router, Cisco router, with an antenna. This is fixed mobile conversion. This is for resiliency, right? So you can use it in many, many, many ways. One is service on demand. You ship the box. You get, as I said, you get the revenue faster, fast activation. A lot of it is management of the box. In all those white boxes that you deploy in my previous company, I did a lot of them. People want them with LTE antenna. So they can have management wherever the boxes are. And sometimes they are in partner network, not in its off-net. So they want to make sure they can manage them regardless of the connectivity from the partner. So this is another way of fixed mobile conversion. IoT, this is another use case. So you'll see a lot of that coming, and for MEF, it's easy. So this is another reason why in 4G it was hard. 4G supported only IP, native. So if you wanted to do carrier Ethernet services over IP, you had to put it in a GRE tunnel, complicated. We did it, by the way. We actually had a birth of feather, both on that, and we discussed it. The good thing about 5G, it natively supports Ethernet. So you can run layer 2 services and layer 3 services over 5G natively, easy. So we'll see that. And for MEF, it's fairly easy. And if you would like to contribute, we are looking for people for that project. Please come see me. That's a nice project. We already have Tilia. If you're familiar with Tilia, they already did it for 4G. Took them a lot of effort to have services over 4G, carrier Ethernet services over 4G. With 5G, it will be much easier. That's all I have. So basically, I hope I can convince you that 5G is more than just another wireless technology. We have multiple transport, just to recap, multiple transport options for 5G. We want to get to application-driven network by doing network slicing. And orchestration is needed, domain orchestration, end-to-end orchestration. And as I said, fixed mobile is coming with 5G. Thank you. Short question? I said I will not take question at the end, right? But I'll take one question, okay. I'll take two questions, okay. Take two.
Class,
okay.
you All right.
Go ahead, I'll take two questions.
Okay, this is very, very quick. So service, you are talking about a 5G service here, right? But looking at the service information model, I mean, 5G is based on the network services, but you're talking about transportation, it's based on like whatever, or MEF or whatever the service modeling. These are different. So how can you design this 5G service based on different service model?
Yes, so yes and no. So first of all, just to clear, when I say service is also a slice, right? So it's we have two types of slices. One is the transport slice, is the underlay, and the service is also a slice of the network. So to me, 5G is just for fixed mobile conversion, it's just the access. And if I can have the same MEF characteristic, whether it's fixed or mobile, the user shouldn't care.
All right, so maybe I'm not clear. So the modeling of the access, whatever, 5G or fixed, whatever, they are based on network service, which is specified by ETSI, NFV, SG. But talking about the transportation, there are another service modeling.
Oh, you're talking about mobile
they are
services.
different service modeling. Yeah.
No, I'm not talking about mobile services. I'm talking about fixed services over mobile. I agree with you. If you're talking about mobile services, it's a different thing. You're right. I'm talking about fixed services that you don't have the fixed network, use the mobile network for that with the fixed interface to the user eventually. So it's seamless.
Okay, then last question. Thank you for the presentation, especially about the 5G topic, which you presented very clearly and gives a clear indication of you how complex 5G will be. My question is more about, maybe I misunderstood that, is LSO the solution to solve every problem which we have with 5G?
I will go back to the slide because, do I have the slides? So, you bring them? Okay. I actually showed it before. Oh, it's the beginning. Let me go. So when I talk, for example, on network slicing, I basically said, and I hope it will answer your questions. So we have LSO for the transport. We have LSO, some type of orchestration for the mobile and end-to-end. The blue is most likely the MEF definition. The yellow doesn't have to be. Would be nice if it will be, but we don't view it that way. That's why we have the two different colors.
Okay, and then I understood it right. And to be honest, then I have a concern that the mobile world will follow LSO and in completely the fixed line world as well. And I think that is really a challenge to convince the entire industry that we have to use LSO, because we have to consider that so many different SCOs up and running, and the message will be difficult to transport to the SCOs that we have to use LSO. I can't imagine that CUP is saying, yes, LSO is fantastic, let us jump on that, and other SDOs as well. And maybe I'm too long in the business and not optimistic enough, but I have my concern.
Klaus, I totally agree with that. I think that what we really need to, we need to solve that. We have to solve that one way or another. In order to solve that, we'll need to have communication between domain orchestration. This is a challenge that MEF is trying to solve. With other standard body, we have liaison, as you know, with GPP, with NGMN. It's a work in progress, and we need more contributors.
Well, it takes time. It will take time, and maybe we have not time enough. That is my point. Thank you.
Thank you.
I also want to add to that. I think we should be careful between resource orchestrator and lifecycle service orchestration.
Yes.
I don't think it's very clear. You can have a resource orchestrator do specific functions that are then orchestrated from a service level, and I think we're talking more of a service orchestrator where a service runs end to end.
End to end, yeah.
Right.